If Web3 is about distributed internet money, then decentralized finance, or DeFi, projects are the protocols, distributed applications, and aggregators that put it all to work. This section provides an overview of DeFi and then introduces core innovations like lending protocols, liquidity pools, automated market makers, non-custodial vaults, and composability. As other use cases, including non-fungible tokens, NFTs, and decentralized autonomous organizations, DAOs, increasingly integrate with DeFi, this category represents a core set of building blocks for the entire of Web3. DeFi apps facilitate financial services directly between users without the involvement of traditional intermediaries. Whereas financial services have historically been reserved for large regulated companies like banks, brokerages, insurers, payment processors, and asset managers, Web3 enables decentralized finance applications through the use of smart contracts, liquidity providers, and users. The DeFi category has grown from almost nothing in 2020 to approximately $27 billion of total value locked TVL across 100 projects as of September of 2022. MakerDAO is currently the largest DeFi app as measured by total crypto assets locked in its smart contracts. DeFi use cases include lending, decentralized exchanges, derivatives, payments, and asset management. Lending protocols enable users to borrow stablecoins and other tokens by depositing and using crypto assets they own, such as Bitcoin or Ethereum, as collateral. Lending and borrowing interest rates are set automatically by algorithms based on supply and demand without a traditional intermediary taking most of the spread. Examples include multi-asset lending asset platform Aave, as well as stablecoin provider Maker. Decentralized exchanges allow the peer-to-peer trading of tokens enabled by automated market makers and liquidity pools without the need for a central party. Uniswap enables the trading of a broad range of token pairs on the Ethereum mainnet and other Ethereum-compatible networks, whereas Curve focuses on the efficient trading of stablecoin pairs like USDC and USDT. Analogous to traditional securities, derivatives projects provide on-chain exposure to a wide variety of other assets, including crypto asset options, futures, and insurance, as well as tokens based upon other securities, currencies, and commodities. Examples include synthetics with synthetic assets, DYDX with perpetual contracts, and Nexus Mutual with smart contract insurance. Payment providers like Flexa, Savalier, and Tornado help facilitate payment and value exchange securely, globally, and privately without the use of intermediaries. Finally, asset protocols, including Convex, Ren, and Yearn, enable a variety of asset management, cross-chain liquidity, and yield farming functionalities. Lending protocols enable lending and borrowing of crypto assets using collateral and incentives. Think of lending protocols as a set of automated algorithms that provide many of the capabilities traditionally reserved for banks, but without any company required. Let's take a look at Aave as an example. Any crypto holder can become a lender or liquidity provider by depositing their crypto assets into an Aave liquidity pool using an Ethereum-compatible wallet like MetaMask. Anyone can also become a borrower, provided they have crypto assets like Bitcoin or Ethereum to deposit as locked collateral. Loans are typically provided in stablecoins, such as USDC, which borrowers can then use however they want, such as paying living expenses, buying a car, or even acquiring more crypto assets. Borrowers simply need to repay loans and interest to receive their locked collateral back. The primary risk to borrowers occurs if the market value of their crypto assets falls to a predetermined threshold, where the algorithms will require them to provide additional collateral or may liquidate their holdings. All of this happens automatically without any team of professionals making day-to-day decisions. Enabling Aave's lending and borrowing are mechanisms to incentivize token holders to participate in the ecosystem's governance, reward lenders for providing liquidity to Aave's markets, and safeguards to secure the ecosystem from shortfall events. Liquidity pools and automated market makers eliminate order books. enabling decentralized exchanges with automated price discovery. Just like lending protocols have algorithms to automatically process the borrowing and lending of crypto assets, decentralized exchanges use an innovation called automated market makers to enable crypto asset trading. The Uniswap protocol pioneered this model, enabling smart contract pairs that manage a liquidity pool made up of the reserves of two different ERC20 tokens. The algorithms use Uniswap's token X times token Y equals K, automated market maker pricing model, where X and Y represent respectively the number of available tokens and K represents a constant. When X and Y are multiplied, the value must always be equal to the value K. Because the relative price of the two pair assets can only be changed through trading, divergences between the Uniswap price and the external prices create arbitrage opportunities, ensuring that Uniswap's prices always trend toward the market clearing price. Uniswap has since evolved its algorithms to incorporate new features, and other decentralized exchanges utilize somewhat different models. However, the key insight is that decentralized exchanges enable any crypto asset holder to participate in liquidity pools that are managed by software, not financial services institutions, creating far more efficiencies in trading crypto assets. In Uniswap's case, the protocol only charges 0.3% for swapping tokens, which is then split between liquidity providers proportional to their contribution to the liquidity reserves. Centralized exchanges, on the other hand, typically charge fees of 1% or more on crypto asset transactions. Non-custodial vaults enable investors to participate in crypto funds without handing over the crypto assets to fund managers. While traditional finance makes extensive use of custodians, institutions that investors trust to hold their cash, security, and other financial assets safely, non-custodial vaults, on the other hand, are smart contracts that allow investors to deposit funds to achieve some investment purpose without the investor ever losing custody over their underlying assets. This opens up non-custodial opportunities for distributed models enabling crypto indices, hedge funds, DAO treasuries, investment clubs, automated yield farming, and many more. For example, Enzyme is a DeFi management system that provides a non-custodial vault that can be used for a wide variety of use cases. Investors can visit the Enzyme website to search for a non-custodial vault that fits their investment objectives. Once identified, they typically need to comply with the chosen vault's requirements, which vary by jurisdiction and type of service offered, to gain access to the vault's whitelist, allowing them to invest. They then lock a value of crypto assets, such as the stablecoin USDC or Ether, in the selected vault's smart contract, receiving vault tokens back as proof of share. The Enzyme protocol allows the vault's manager to make investment decisions based upon some number of predetermined transparent parameters. Managers can also charge predetermined management and performance fees. However, they can never withdraw investors' funds because investors maintain custody of their respective shares of the fund. Investors can monitor the vault's performance in real time and typically are able to exit at any time by exchanging their share of the vault's token that they hold for the underlying value.
The composability of crypto assets drives higher rates of innovation, enabling compounding utility and increased returns. Composability is the ability of decentralized applications to interact with and be built on top of each other. Syntactic composability enables every smart contract published on a public blockchain to be called by other smart contracts. Atomic composability allows the bundling of several small transactions across multiple dApps in a network into a single transaction that are executed together. And morphological composability facilitates the creation and utilization of application-level standards across a wide range of elements, including tokens, name registries, and wallets, which help to make functions and interfaces across dApps interoperable. Now, why is this important? Because, as Chris Dixon from Andreessen Horowitz has said, composability is to software as compounding interest is to finance. It's sort of this magical thing where if you get it going, it has a sort of exponential hockey stick. In other words, composability lets developers mix and match software components like Lego bricks. Each software component only needs to be written once and can then be reused wherever needed.
Composability is contributing to what some have called a Cambrian explosion of innovation in the DeFi category. Let's look at a modified DeFi stack to explore this composability-enabled innovation. Layer 1 and 2 blockchains provide the settlement layer for DeFi, as they're used to facilitate, validate, and secure crypto asset transactions. Additional crypto assets are built in the asset layer, enabled by ERC tokens, for example, on Ethereum, as well as comparable standards on other blockchains. Protocol standards that determine different use cases, such as decentralized exchanges, lending, derivatives, and payments, can be built on top of these foundation layers. As we've discussed, the application layer includes a wide range of user-oriented applications that are built on and connected to protocols, usually delivered through web-based interfaces. Yet it doesn't stop there. An aggregation layer, sitting conceptually on top of the entire DeFi stack, utilizes composability to aggregate and add value to public DeFi dApps. These include decentralized exchange aggregators that optimize market liquidity and do least cost routing for transactions, as well as asset and yield management dApps, leveraging non-custodial vaults. To bring it all together, DeFi puts distributed internet money to work. While we barely scratched the surface, you now have a working understanding of DeFi basics. We've discussed how DeFi applications facilitate financial services directly between crypto asset users, without the involvement of traditional intermediaries like banks, securities firms, and insurers. We've also explored some core enabling DeFi models, including lending protocols, liquidity pools, automated market makers, and non-custodial vaults. You now have some intuition about how composability allows public Web3 stack components to become Lego bricks that drive exponential innovation. In the next video, we will shift gears as we look at the emergence of non-fungible tokens, NFTs, in the context of the metaverse. If you found this video useful, please like it, subscribe to the Accelerating Biz channel on YouTube, follow us on LinkedIn, Twitter, or Medium, and visit acceleratingbiz.com for additional Web3 insights and resources. If you have feedback or questions, contact us on any one of these channels. Thank you and see you soon.